All right. Hello, everybody. Welcome to my talk, Building Modern React Applications. My name is Glenn Reyes. I'm an independent software engineer based in Vienna, Austria. And I work mostly with React and GraphQL day to day. And I also help running the React Vienna meetups. So if you ever get the chance to get to Vienna, please reach out to me. I'd love to meet you there. And also, I'm Glenn Reyes on Twitter and Instagram, but without the E's. So if you don't follow me yet, please give me a follow. So let's kick off this talk with the question, why do we love building applications? But more especially, why do we love building modern applications? So the term modern implies something new, something that is updated, or something that's fresh. And especially when we create something new, it's like we get this kind of like joy and happiness to our life, which is nice. And especially when it's new, everybody loves new things, and everybody even better when we get new things, like when we go shopping or something or buy new stuff. It's similar to code. When we go to GitHub and see new things, we basically enjoy them, and we just easily fell in love with it. And in web development, new things are coming every day for a reason. Like, they're new. And when we build application using new tools that we have never used before, they intrinsically let us basically step out of our comfort zone, and we learn from them. So building modern apps lets us keep moving forward because we are surrounded with new tools, and thus they allow us to be creative, right? So they allow us to build great things. And here is a nice quote from the Dutch post-impression painter Vincent van Gogh, saying, "Great things are done by a series of small things brought together." So let's take a quick step back before we go into React and ask what modern actually means. So in its simplest form, the term modern implies the up-to-date, a current development, or a spirit in a step with its own time. So this is like a definition from David Alfred, which is quite interesting, like a step with its own time. So we can think of it like, especially in web development, the bleeding edge, which is not like something that is nailed into history, but it's something that is kind of moving, right? So it's exciting stuff that we want to use, but probably shouldn't for use in production at least. And the bleeding edge on the web is a little bit interesting because in the web we see new libraries released every day. So anything that came out yesterday is generally outdated today. So we basically call them also legacy code. So it's stuff that is kind of now less exciting anymore, right? Now, in this talk I want to focus on building modern React applications. Actually, how many of you have experienced building React applications or work with them? It's kind of like 50%, which is quite nice. How many of you have shipped React hooks in production? Probably the same amount of people. How many of you have shipped React Suspense, the concurrent mode in production? Not a great idea. So React solves many problems that we have faced in web development. For example, the Facebook React team, they have been so busy shipping new features along with building the new Facebook app. So it's no wonder that React is constantly growing, and it's getting even better over time. So here's also an interesting result of developer satisfaction from the State of JS 2018 survey. So here's a comparison of React and other popular front-end frameworks. So you see the red bar, which says people who are using it and would use it again, whereas the blue bar who are people who have never heard of it. So React, you can see here on the left, is at almost 65%. So it's almost a third of people who used it and would use it again. So it's actually quite amazing. Now, what are the best ways actually to start when it comes to start building a new React application? Well, there is a ton of great starters and boilerplates that solves most of our use cases and help us to get jump-started. So basically, we shouldn't waste our time configuring Webpack, testing in that environment at these days. So back in the days when I learned React in maybe 2015, I had to do that. So because there wasn't tools that existed like Create React App, Next.js, and Gatsby. So when you get to Create to start building a new app, I think most people face into these three frameworks that I've also just said. So one is Create React App, which is a zero config setup, which is easy to set up, easy to start. It's completely client-side, and it's also probably my personal go-to when it comes to building smaller applications. It has all the best practices and a great community support around it. The other one is Next.js. It has a great developer experience. Comes also with zero config. It has server-side rendering support out of the box, dynamic routing, and many, many other features. So this is perfect when it comes to building like more complex applications. And the third one is actually Gatsby. It's great when you build things like that has many, many static sites, like blog pages or marketing sites, for example, as it comes with a great progressive web app setup out of the box, and it comes with a great plugin ecosystem around it. So most of the other third-party libraries that you might need, it probably has it as a plugin, which is really, really nice. So I'd encourage you to take a look if you want to start building something new into one of these three and find something that fits best for you. So, but also, it doesn't mean that you have to choose between these three. Like others are fine too. So use whatever works best for you and your team and what solves most of your use cases, right? Now, what are the benefits of building apps with a modern stack? Why building apps with a modern stack, actually? It is amazing to use and contribute back that comes from the open source community. Like popular libraries are being actively maintained. So, for example, if you're stuck, it's likely that your bug has been fixed elsewhere. So questions are answered quickly, and so on and so forth. So working with a modern stack is really powerful, actually. And what makes people also feel so powerful is actually people love fixing bugs in others' code. So you don't have problems in your own code. You gotta find it in other people's code. And that's why people love solving problems. So, and if you think about it, if there is no problems, what are we gonna try to solve then? Well, otherwise there is no reason why we would web dev, right? So if there is no problems, why are we then working? Now, how are problems solved in React today? Let's talk state management for a minute. So state management is actually a problem on its own. That's why you see solutions like these that are trying to solve that. So there is Redux that has been around for many, many years. So by many, I mean probably 2 or 3 years. And MobX is actually not that popular like Redux. And there's also Apollo, which is also trying to solve state management in some way. But especially MobX. MobX deserves, in my opinion, more love from the community, actually, as it's so underrated. So there is a tweet from Kenzie Dodds, who tweeted about a month ago about it. He's like, "You're better off than with MobX than with Redux," which actually is amazing. So Kenzie Dodds is a big influential person from the React community, and actually, I have never tried MobX though. So. And last year, the React team has shipped and improved and its own state management library with the new context API. So actually, the context API is actually not really new, but the new API kind of makes it new. So you don't have to depend on third libraries anymore just for state management. So no need for installing Redux, Saga, and all other package JSON libraries. So you can actually just use React. Why not? So React itself basically is your state management library. So here's a quick look, actually, how it looks like. So you have your theme context, where you create a context and pass it an initial value, like the light theme. And then you have your app, where you wrap your entire component with a context provider, right? And then you have your, and at any arbitrary point in your tree where we use the context. So in this case, we call the React.useContext API and pass it the theme context that we have just initialized before. And here we use basically the theme, and apply the context, the state that we have from the above, right? Here again, displayed in a diagram. So we have our app, and then before we have our content, we have our theme context provider wrapped on it, and then an other component, and somewhere we use the context, for example, in the theme button, to render some context state. So other components are not being re-rendered, right? But context doesn't need to be globally accessible. For example, imagine you have this Twitter home feed, like a Twitter Lite home feed or something, where you have your composer at the top, and then in the middle, in the content, your Twitter feed. So in JSX, probably the whole thing would be your app component, right? And if you create a context that has information about a feed, what you want is probably to wrap it as close as possible. So in this case, we wrap the feed context as tight as the area that is needed. So here we skip basically the tweet composer at the top, right? And in contrast, for user data, we only need it in the composer for our avatar. So in fact, we could actually do it even better. So we could actually put it as close as only the avatar. So maybe it may be actually a better case to wrap it only around this, because we don't need it in our text or in our button, right? So summing up, put context state as close as needed, especially the provider. Now, let's talk a little bit about what's new in React. So there's React Hooks, which has been released earlier this year and has been a big movement for the React community. They are a new addition since 16.8 and let us use state and other React features without writing a class. And basically, we are able to use state and lifecycle capabilities inside of function components, right? So here's a quick example. Basically, we have our function, and then inside here, we call the React.useState and pass it an initial state. And what we get out of it is like a state, the count, and a setter, which is the set count. And in our render, we basically use them. We render our count, and we use our setter in our event handler in this case. So it's pretty interesting. So function components, and there is no more stateless components. So previously we had stateless components, which is not very common anymore, and we now call them function components since then, as they may contain state now. Same with stateful components. They doesn't exist anymore. So they are now just simply class components, right? As function components can also include states. So as we have almost everything in function components, like states and lifecycle methods, what happens to class components then? Are class components still a thing? So yes, they will still stay around. There are still valid use cases, for example, like arrow boundaries or component did catch lifecycle log, which is not been implemented yet for React hooks. So use hooks for new components if the team fine with it, and see if it helps. And don't rewrite your entire app, and keep existing class components as they are, and rewrite them only if it makes sense. So there is no need to refactor your entire React application into React hooks. So keeping classes around, there are still good use cases to still use them. So only apply React hooks, or only try them out if you're gonna build new components and see if it helps. In my cases, what I've found really beneficial from hooks was that you're able to co-locate same capabilities, same features into the same place. So you basically can, especially with creating custom hooks, you're able to put them all together. Whereas in class components, you have them separated into between your lifecycle methods, which is a huge advantage of that. The other big thing that is actually coming soon is concurrent mode. This is, in my opinion, something that will have probably a dramatic performance impact to the user experience. So what is the experimental concurrent mode? So concurrent mode is a set of new features that helps React apps stay responsive and gracefully adjust the user experience, the user's device capabilities and network speed. So one of the mechanisms to achieve this is suspense. So what is suspense? Suspense basically lets components wait for something before rendering. So as of today, in the stable release, it only supports loading components dynamically with React.lazy, aka code splitting, but with concurrent mode turned off. And in the current experimental release, we now see ways trying to use suspense for data fetching and concurrent rendering. The general idea is to allow components to suspend their render. For example, if they need extra data loaded from external sources. So once all the information is there, React will retry to render the component and render what you wanted. So here's how to use suspense with code splitting. So you have your suspense wrapper, and in there you pass your fallback prop with, for example, a loading indicator, and while the heavy component is being loaded, you might eventually see the fallback element at a certain holistic threshold. So, and there's a lot of other React features, for example, like fragments, React memo, portal, and profile. The new profile API, which has been released over time. And I can't go much into details, but I think this is a nice overview to see them. Now, let's take a quick look into some common React patterns that we have seen over time. So higher order components. Higher order components is basically a function where you pass your component and get a new component out of it. The idea about that is that you're able to inject new props into your current component that you have. There's also render props, where you basically, or children as a function, where you basically have, where you basically call the children as a function, and have also same capabilities like the higher order components, and you're able basically to isolate props between that. And we've heard about hooks already, which is like the new way to put state into function components. Now, how do we fetch data in React? There are three approaches how we can achieve that. So one is the fetch and render. Fetch and render, we start basically by adding or by calling fetch inside our component did mount lifecycle hook, for example. And in contrast to function components, we can do that by using or utilizing the use effect hook by calling the fetch data. So we call fetch data, and then say if the data is there, we pass we call the set state function and set our state, set our data to the state, and otherwise set an error to the state if it failed. Now here's an example how it looks like on a timeline. So you see here the timeline on the left and the UI on the right that we have seen before with a Twitter Lite home example. So first we download our code, and once the code has been downloaded, we then start rendering a loading state and start fetching the user data. And once we have fetched the data, we render our user data, which is here in our composer, and start loading the UI for the feed and start fetching for the feed data. And once we have the data, we render the data to the UI, and that's it. We have basically our page loaded now. So you notice there is a waterfall problem here, right? So which can lead to actually huge loading times when it comes, especially when it comes to more complex use cases. So the second approach tries to solve the waterfall in some way, which is called fetch then render. So the way how it works is to intrinsically start fetching multiple data sources at once. So instead of just fetching one data source, we utilize the promise.all API. So instead of calling multiple use effects in multiple components, we have them all at once, right? Which is quite interesting. So let's see how it looks like. So we download our code, we render the loading state, like both loading states from the composer and on our feed, and we start fetching both. And then after a time, the user data has been finished loading. So, but we still have to wait. And then after a time, we are able to render both. So you can kind of see now actually the drawbacks from that. Because we have actually the user data finished loading, but we haven't rendered it yet, right? Which is actually not very what we intend to do. So I know this problem can be fixed at some point, but in certain use cases, these can be very complex as it's not so idiomatic enough when we write React. So the third approach, render as you fetch, leverages Suspense that is trying to solve all of these problems. Here we're starting fetching first, then start rendering. So we download the code, we basically fetch the data and also start the render right after it. And notice that we don't see anything yet while we have started to render. And at the best case scenario, we render UI much earlier as we just received our data and were able to render it immediately, right? And at a not best case scenario would look like this. So we download the code, we fetch our data and start also the render. And then we hit a certain threshold, like a time limit. So we start render a loading indicator in, for example, in our composer. And as time goes by, we hit another limit. We start render the loading indicator of our feed, for example. And after a while, the feed has been loaded, so we start rendering this, and then our composer. So eventually, you receive all the data and render everything to our UI. So again, this approach will actually dramatically change and directly impact to the user experience performance-wise, as we're also able to, for example, select which one of these should be rendered first and all that. There is a lot of capabilities that Suspense allows us to do user experience-wise. So React Suspense is really, really exciting, but it is not available in a stable release yet. So I'd encourage you to look into the React.js docs on the reactjs.org/concurrent if you are more interested in this topic. And there's a lot of great code sandbox sample that you can check out if you are interested more into that. Now, let's talk about systems, like the things that gives us robustness and consistency. So one system is, for example, type systems. So why would I need a type system? By writing types, we are basically getting the type safetiness and the robustness, which gives us confidence and awareness when we are writing code. And it gives us nice things about like auto suggestions. So there is less to think about when we are trying to find something in the docs, right? Because it already pops up to you. So basically, auto suggestions allows us to show what types are actually possible and whatnot. And there are also, like with type systems or static, especially static analyzed type systems, allows us to basically dump runtime types, for example, like prop types. So, which means it reduces also our bundle size. So with type systems, for example, like Typescript or Flow, we basically don't really need runtime type systems anymore. So here's a quick example how a Typescript typing look like. So in our editor, the editor shows us which props are available and whatnot by just starting typing because of that. And it also is able to show us what kind of type it has and all that, which is really amazing. And as already mentioned before, there are two major type systems that are well adopted. So one is Typescript, which is coming from Microsoft, and the other one is Flow, which is created from Facebook. And TypeScript is more popular in the open source community, so it keeps growing, and it's also my personal preference. And I would start adding it for more awareness of typings and gives you more confidence about it. The other system is design systems, which are quite fundamental when it comes to consistency in UIs and components. And it's important not only for consistency, but it also saves us time and work for recreating new UIs over and over again. So style guides helps us to document common UI components that are used across the company. So not only for one app, but it can be used for all kinds of different apps in the organization. And especially living style guides, like living documentations, are great, as they are both great for working on a single component and also trying them out to display to any kinds of different variants and states. So the cool thing about it is also when you start working on a component, you can actually work on your documentation because as it's also the exact thing as it's rendered in your application. So we basically work on this side, and it applies also on everywhere else. So when you build a design system, what you want is also you want to make sure that we have like sizing scales for fonts, spaces, or media breakpoints. And we want to add theming constraints to contribute to a consistent UI. So here's a quick look how theming with a styled system for style components look like, for example. So on the left, you have our object of our theming constraints. For example, we have breakpoints, like 3 major breakpoints, and then we have our font sizing scale, which we're able to use, our spacing scale and colors and what kind of fonts we have, right? And on the right is one way how how these can be applied to our components. So instead of like manually using CSS, which leads to lots of inconsistencies, we basically have a constraint use of, for example, spaces. So, for example, the MR prop that you see here is not 2 pixel, but it's on the spacing scale on the second index, so it's 8 pixel actually, right? Now, how do we architect modern applications, React applications, using a type system and design system? It's really hard to answer this question because we gotta make many different decisions and really small decisions when it comes to adding both type and design systems. So for example, how much value will XYZ bring, or how much time will we be saving by adding XYZ? And also, actually, is modern the best? There's a reason why new things are coming out, keep coming out. Also, higher order components, for example, are still valid use cases, and render props are 100% fine. So just because something new has been released doesn't mean that you have to use this new thing. Old things are also fine too, or like keep good practices that works in the past. Like use cases from high order components are still there, so keep using it. So think from the inside. What makes you more productive? What is more enjoyable to work with? And also use what works best for you and your team. Class components won't go anywhere. They still stay as they are. And I would keep using them. It will be fine, actually. So also, they will become legacy code once. And if they're great, we'll enjoy them. We'll enjoy using older code even more. So write the best code possible. And keep using what you know best. Do what keeps you working fast and efficient. And most importantly, never stop learning, and especially never stop learning new things. And here are nice resources that I've found most effective to keep me informed with the latest updates of React. So I'd encourage you to check them out. And if you're interested about what's next and so on. That's everything I've got. Thank you very much.